Hey, welcome back to another video with Wood, Brass, and Glass. I'm Isaiah, and today I'm going to be talking about the law of squares in relation to the Searl Effect Generator replica. So stay tuned. We're going to talk about this system, the incredible math it has. So stay tuned. Law of squares. What is law of squares? Well, for starters, it's a matrix of numbers put into a grid. A lot of you, actually probably most all of us, have done addition, multiplication, and subtraction. But usually it's addition, multiplication, these kind of grid configurations. So this is known as a magic square. Nothing too magical looking about it, of course. It's just numbers in an ordered process, 1 through 16. Now, you can make a 2x2, 3x3, or 4x4 square, whatever you want to do, 5x5, 6x6, and on up. But because the Searl Effect Generator is built upon this as a blueprint, the guiding principle, this is what John Searl came up with through a series of dreams given to him when he was a boy. So we're following the steps of John Searl. I'm not changing it, not altering it. So how do I go about deciphering this matrix? Well, this is all in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. When you add these all up, you get the totals. Now diagonally you get some 34s, which we're looking for is 34s, but here you don't get anything. So what if there was a way with having an orderly input but a chaotic output? How are you going to have a chaotic input, so to say, of numbers arranged chaotically, but you have an even output? Let me show you. All right. So here is squares arranged basically what looks like chaotically. 1, 15, 14, 4. Why is all these things scattered about so disorderly? It's actually not disordered. These are strategically placed. Now, if you notice, I've highlighted these in green. All the outputs are ordered. Now check this out, and you can do this at home. You add this number, this, that's 34. You add these four numbers, 34. You add these to 34. These four numbers equal 34. This row 34, this row 34, this row 34, 34. The four center squares, add them together, 34. You add this one, 34, this one, 34. This, 34, this, 34, this, 34. You can't escape it. So cool. So then I find similarities in the patterns. I love this kind of stuff. So half of 34 is 17. What do you get with this? 6 and 11, 17. 7 and 10, 17. You find 17 scattered all throughout here in very interesting arrangements and patterns. So, and you find a whole lot of other numbers, 21 different things, 18, 16, 18, 16. You have these groupings. And then I put these together in evens and odds. So you have these groupings. Here's odd, 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 even, 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 even. Now, okay, this is just math. How did John Searl take this wild assortment of numbers, which to the normal person, including myself up until just a few months ago, could not make heads or tails of this, aside from just using this set to figure out the weights of the rollers? Let me show you. Here I've laid out, for more simplicity, law of squares numbers. I've removed all the additional numbers because they're irrelevant to this conversation right now. So there's 4 pieces of one segment of a roller. This is the rare earth segment, and this is composed of exactly 13 grams of rare earth material. Now, John Searl used neodymium because there was a glass factory next to him that he could literally get this stuff for dirt cheap, and I'm not kidding, dirt cheap back then. Then you have the magnetic layer. So presently I'm using neodymium-based magnets and putting impressions into them. John Searl used his own custom blend of magnetic materials. He was the first one to ever come up with putting neodymium into his magnetic material, but it was only maybe 1 to 1.5%, very trace amounts. Here you have, so this is 10 grams on the magnetic layer. Here you have 7 grams for the copper layer. Then 4 grams for the insulator. Now for this purpose, I'm using Teflon. I'm also going to be experimenting with nylon 6. Each one of these, 13, 10, 7, 4 equals 34. So how do you go about scaling this up? Like, this is the base weight you can start at, according to John Searl. 34 grams. So you assemble these. You have your insulator. You have your rare earth. Then you have your magnetic material. Now in a setup I'm doing later, this will be put together with a vise, of course, but for all intents and purposes, I'm just doing this by hand for video demonstration. And then, last but not least, the copper layer. Beautiful to look at, symmetric. Here, you need to do custom magnetizing to complete one of these segments. In the full SEG, there's 528 of these segments. So, some of you might recognize these numbers I'm spitting out. 528 is a very important number. So each one of these with the hole is a percentage of the hole. The insulator layer is 11.76%. Copper layer, or the emitter layer, is 20.59%. The magnetic layer is 29.41%. And the final one, the rare earth, which is the electron source, is 38.24%. Here is version 6 of the SEG. I built this one last year. I am presently working on version 7, which will be about the new upcoming video series I'm making here. So you have similar layers. Ooh, this is definitely magnetic. There we go. You have identical similar layers. You have the rare earth. You have the insulator, Teflon. Magnetic layer, the magnetic layer. Then you have the copper emitter. So that these rollers, which there are 8 segments in a roller, which you see here, 8 segments. This is a prototype roller, it's not finished. 8 segments to a roller. To the first ring set, there's 12 rollers. Second ring set, 22 rollers. Third ring set, 32 rollers. 66 rollers to complete an entire SEG. These would be inductors for harvesting the electrical output. A lot of people get this system confused. They think it's over unity. You put something in, you get a whole lot more out. It's not like that. This just converts incoming thermal energy, mainly, you could say it's fuel source. Thermal energy through the core from 3 dimensions and outputs in 2 dimensions radially. Electric field, you have magnetic field going up. Motion is horizontal, and electric field is heading out radially. So 3 dimensions in and 2 dimensions out, much like you see on the rings of Saturn. But back to laws of squares. So using the same principle of each layer, 13, 4, 10, and 7. Well, okay, wait a second. This one's massive, this one's tiny. This was my problem with understanding law of squares. How do I get from here to here following law of squares? Because I can see this with the square, a 4x4 grid, shows this plainly, all those numbers. But then how do you jump to here? Well, there is a logical system that you follow using the percentages between the numbers. Just as these percentages show. 38, 24, 29, 41, 59 point, or 20, 20.59 and 11.76%. So you keep these correct, representing the volumes in a square, which John Searl said was each square represents a volume. This volume is 20.59%. This volume of the magnetic is 29.41. This volume of the rare earth is 38.24%. This volume of the nylon, or PTFE. PTFE, Teflon, is a way more denser material, nearly double the density of nylon 6. However, you can use nylon 6. So one of the things I've learned through this research, this is another critical part, it's not just merely an insulator layer. It's negatively charged. There's not a lot of research out there about negatively charging plastics. The plasma channel guy has done it. There's been research, Floyd Sweet would charge his ceramic magnets, his ceramic barium magnets. And John Searl also negatively charged all of his insulator materials. Now, it has yet to be seen by the work that Fernando Morris and Jason Brubelli are doing if Teflon will produce a working model. All I know from history is John Searl did his working models with nylon 6. This is a Teflon ring. This here are nylon 6 rings. This took weeks to create all these. I did them all on a 3D printer, and they're all perfectly sized down to the gram. And all they require is charging electrically. There will be a following video eventually showing how I do that, because I still have to do all the testing with charging these negatively on a Van de Graaff generator, heating them and then charging them. But they all need to be polarized electrically. That's a lot of rings, folks. A lot of rings. Ha! Silly me. I forgot like the most critical thing I wanted to show you. Okay, so building this according to law of squares, we got the basics down, right? So we got how to find the correct weights to build the rollers, or at least the right sizes. So using a mechanical calculator online, which I'll provide the link, and here I'll show in a second how I do it online, an online calculator to get the exact sizes for the rollers using these weights. But before I move on from this, something very special and unique about John's SEG, it didn't just use plain magnets at all. He had frequencies put onto magnets. He superimposed frequencies, and he harmonized the whole system using these weights so that everything had a resonance point to it, mechanically and electrically, using special magnetizing. So, okay, well, it has frequencies. What frequency? It's right here. It's right here. Right here. How do you get the magnetizing frequency? According to John Searl, it's right here. Okay. This plus this and this and this plus this plus these plus these equals 136. The entire square. 136 is the magnetizing frequency. And that's the one he said to print, put on the stator, as he called it, plates, the plates and the rollers, magnetize it at 136 hertz, and that's what got the system to take in chaotic energy, all chaotic, all randomly ordered, but not so random, and output is harmonious, non-chaotic. Coherent is the better word, actually. Incoherent to coherent. As for the other setup I had, everything was coherent in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. Oh, it's all coherent going in, but everything comes out all incoherently. Yeah, producing heat and friction and wear. Using law of squares, disorder, incoherence goes in, coherence comes out. A coherent system. No wear, no friction, cold. So I have another thing, maybe not one more thing, but something else I want to show you guys that's pretty cool about squares. All right, here is a three-dimensional model I built of squares. Here you have the square face that I use, but then I also integrated all these numbers so that they line up to form actual real cubes. So they all line up three-dimensionally. I built a three-dimensional cube shape. Now, interesting, yeah, but what I also learned, I have yet to build a clear one. John Thomas, who worked with Searl back in the 90s, said when you build a clear one and run all the numbers, like connect all the numbers through it, forms a vortex. I tend to believe that. But what I also discovered in this, which I love, it actually comes out in the shape of a cross. How about that? The cross that Jesus died on. I love it. Okay, so I also follow the same numbers with some yellow highlight. It goes through here and weaves through here. So when you fold this together to make a three-dimensional cube, it actually forms a line of access. So that what John says, because the numbers could rotate around, these numbers could flip, these numbers could flip, but this was the line, the access line essentially. So it meant this was rotating, and that's one of the reasons he came up with, oh, these proportions of materials are spinning, something's spinning. Okay, well, when you build a three-dimensional cube, that line, you can see here, is the access line, and it rotates, it rotates around, which I need to build this thing, and there we go. So that is the access line. It spins around. It's a rotating system, just like you have here, a rotating system. Rollers rotating around the stator. All right, so that concludes it for today for squares. I'm going to be showing a video on my Patreon account soon that will clearly detail how to use this number grid to figure out the weights that you need to use for building the stator, all three rings. I have been working for months and months and months on ChatGPT to train it, how I can give it basically three numbers starting with the rare earth. This is the starting point, the focusing point. You get the weight, you get the height, the width, and the gap distance for the roller. You can basically give ChatGPT four numbers, and it will build all three rings for you. This is the starting point. This is all you need to determine your stators and your roller and your stators. It's the key to the whole device, is this starting point. You get the starting point right, you can build all three rings. So in a later video, I'll be showing the stator. But in the meantime, let's jump over to the materials weights calculator online, which I'll provide the link in the bottom in the description. So anyone here can go and use that system, that website. So, okay, I'm just going to stop talking and get over to that site. All right, here is the materials weight calculator that I've been using for 10 plus years. It's changed a few sites over, but I will list this web link in the description below. You can input all sorts of wonderful parameters, the material, the density, the cross section, and that is essentially these. Well, for this, it's the rare earth segment. For mine, I'll be using a density of 6.65 and a width of 0.891, I believe, because I like to be specific. Okay, say mine 2. There we go. So let's say if you wanted to make the roller section a little higher, a little taller, well, then you would change that to be, let's just say this, and then you reduce this down to get your 13. There we go. Now, you can also change the density. For me, I'm using a mixture of rare earths, not just plain pure neodymium like John Searl used. So if I booted that up to neodymium, you'd have 13.7. So you can reduce that to about here, and you got 13. Very awesome weight calculator. So I hope you feel free to use it. And I've been using it all this time for all layers, and I found it to be extremely precise. Especially when giving it to suppliers, I always add a little bit extra, and then I can size it down here in the shop to meet my exacting specifications. Hey, I just want to tell you thank you for watching my video. This concludes it for today for Introductory Law of Squares. There will be many more videos coming about, more things I probably haven't passed on and shown about laws of squares that I've learned, but those will be shown in upcoming videos. My Patreon account will be showing the nitty-gritty details, all the fun stuff I've learned that I'll be hosting there. But YouTube will be showing all the main general ideas, discoveries, failures, everything. I'm not withholding anything on this project. So I hope you've enjoyed this video, and take care. Join me on the next one. See you soon, everybody.